So in this lesson, what we're going to do is build upon the foundation that we've already laid with mean and standard deviation. What you previously know about standard deviation and mean is I've had you guys look at and calculate percentages for data values that are exactly 1, 2, or 3 standard deviations from the mean. What if they weren't exactly 1, 2, or 3? What if it was a 1.5 standard deviations or 2.5 standard deviations? How can we calculate percentages that way? To start down that road, let's just practice doing and calculating the fraction amounts of standard deviation. Here we have this first example here is you looking at U.S. adult shoulder width. For men, the mean shoulder width in this data is 17.7 inches, and the standard deviation is 0.7. And I've put all that data already over here in the left bell curve. And then notice that the women has a standard deviation, a mean of 16 inches and a standard deviation of 0.8, which I put right here. So what we're looking at here in this first example, suppose Mary has a shoulder width of 17.5 inches and Daniel has shoulder width of 19 inches. Which person has broader shoulders as compared to their own gender? So what they want us to do is take Mary's shoulder width of 17.5 and compare it to her own gender. So to do that, first, let's notice that Mary's shoulder width is 17.5 inches. Looking closely at the bell curve, notice it's not one of these values. If we had to ballpark it, it's probably about right there. So as we can see, her height, her shoulder width, is about, let's see, maybe 1 and some change. Standard deviations, not quite 2. Now let's take a look at Daniel. Now Daniel had a shoulder width of 19 inches. When we look at his shoulder width, his would probably be about right here, right? If that's 19.1, and about 19 is about right there. Notice that his shoulder width is about 1 and some change. Not exactly 2. So how are we going to compare these two? Well, let's figure out how many times exactly each person is higher than the standard, than the mean when we're just comparing it with using standard deviation. Here's how this will work. Let's take Mary, and she had her shoulder width of 17.5. Let's subtract the mean. In her case, the mean was 16. And then what we'll do is once we subtract it, we'll figure out how much that distance is, and then we'll divide it by the standard deviation to figure out how many times away, how many standard deviations she is away from the mean. So her standard deviation is the 0.8. So doing that little subtraction first, 17.5 minus 16, we get 1.5, and then we have to divide that by 0.8. We divide that out. We get, let's see here, 1.875. All right, let's do the same work for Daniel now. So Daniel had a shoulder width of 19. Let's take his, figure out how many standard deviations he is away from the mean. So we'll take the 19, we'll subtract the 17.7, because notice the 17.7 is his gender's mean, and we will divide that by the men's standard deviation, which is 0.7. So when we divide that, or subtract that first, here we have 1.3. Divide that by 0.7, we're going to get a really squirrely decimal here. And what we get here is 1.857. So taking a good look at both of these numbers, what both those numbers mean, once again, is the number of standard deviations it is away from their mean. So Mary is 1.875 standard deviations away from the mean, and Daniel is 1.857 standard deviations from the mean. So notice that Mary has a larger, is further away from the standard, from the mean than Daniel is. So Mary, in this case, has broader shoulders compared to their own gender. Let's do this again. So suppose Emma has a shoulder width of 14.7 and Dominic has a shoulder width of 16.8. Which person has broader shoulders as compared to their own gender? So let's do the same thing with Emma. So Emma was 14.7. Let's subtract the mean, which is 16.0. And then let's divide that by the standard deviation, which is 0.8. So 14.7 minus 16 gives us negative 1.3. And then we'll divide that by the 0.8. And that gives us negative 1.625. So what to make out of this is, if we think about Emma's number, notice her number was under the mean. Her 14.7 would have placed her right about hereabouts, right? So it's a little bit more, or a little bit over one standard deviation under the mean, but not more than 2 standard deviations below the mean. So under the standard deviation, that'll just compute out to be a negative number here. All right, Dominic, let's see what happens with you. So 16.8. Yep, he is under the mean also, so we're going to get a negative number here. So 16.8 minus his standard, his mean, which would be 17.7, and then we'll divide that by 0.7. So we get negative 0.9 divided by 0.7, which gives us about negative 1. Let's do 2, and it was 8.6 approximately. So be careful with this one here. Who is actually further away from the mean? In this situation, Emma is actually further away from the mean than Dominic, because her number is closer to 2, negative 2, than Dominic's. So in this case, once again, the females win. Girl power. So what I'd like us to think about down here, to sum this up, is if we take our data value that we're given, we subtract the mean, which we'll write there as mu, divide it by the standard deviation, what we get, and what we call these numbers here, what we call this number here, all these numbers that we're finding here, these are what we call in the math biz a z-score. And what we need to do is start to get ourselves pretty familiar with these z-scores. This is going to become a pretty big deal going forward. So to find that z-score, what we do is we take the raw score, this guy right here, and then we subtract the mean, and then we divide by that standard deviation. And what this tells us here is it tells us the number of standard deviations that we are away from the mean.